image formed by an extended object onto a plane mirror. Now in this case we have taken object AB, which is an extended object which is made up of multiple point objects. This is the mirror M dash mirror. This is the back side of the mirror, which is shown by oblique slanting lines. This is the front side of the mirror. The object is kept towards the front side of the mirror, which is towards the left side of the mirror. Now this extended object is in left side of the mirror, has light rays falling on the reflecting surface of the mirror. So there are two incident rays which are shown here for the point A of the extended object. Here these 2 points are falling on the reflecting surface of the mirror. Now the incident ray falls on the reflecting surface of the mirror, and the point at which it falls is called as the incidence point. So here this incident ray is falling at this incident point, which is the C, and this incident ray is falling at this point, which is the point of incidence, which is labeled as point D. Similarly, the point B of the and B of the extended object is sending incident rays which are falling on the reflecting surface of the mirror. So this incident ray is falling on the reflecting surface of the mirror at point of incidence E, and this incident ray is falling on the reflecting surface of the mirror at point of incidence F. We have also shown perpendicular to the point of incidence, which is also called as normal. So the normal is making an angle between here is making an angle of incidence I with the incident ray. We have also shown reflected rays which are originating from the point of incidence and going in opposite direction away from the reflecting surface of the mirror. So here at point D, which is the point of incidence of the incident ray coming from the extended object point A, this reflected ray is shown here in this direction. Similarly, for point B of the extended object, the incident ray falling at point F is sending a reflected ray in opposite direction away from the reflecting surface of the mirror. Now this incident ray is also making an angle of incidence with the normal here, which is shown here from the point of incidence F. So we have two angles here. There is angle of incidence between the incident ray and normal here at the point of incidence D, and angle of reflection between the normal and reflected ray at the point of incidence D. We also have angle of incidence at point of incidence F. This is the incident ray making an angle of incidence with the normal, and there is angle of reflection between the normal and the reflected ray at point of incidence F. When we trace this reflected rays backwards, which are shown as dotted lines here, we get 2 points, A dash and B dash. These are towards the back side of the mirror. So we extend the incident ray as well as the reflected ray towards the back side of the mirror, so that we get 2 points, A dash and B dash, and when we join this through a dotted line and arrowhead directed upwards, we get an image of this object, which is AB. So this extended object AB forms an image which is extended object image A dash B dash towards the back side of the mirror. It is shown as dotted line because it is not a real image. We have seen previously that this image which is formed towards the back side of the mirror and which can be seen only by looking into the mirror. This is the reflecting surface of the mirror. So if we have to see this image, we have to look into the mirror from this side. So this image is called as virtual image. Now we see that this image has arrowhead going upwards, which is similar to the extended object. So this is the virtual and erect image. Now we also see that the size of the image is same as the extended object. Okay, so the image is virtual, it is erect, it is same size, but it is on the back side of the mirror. And we also observe that the distance of the object from the mirror and the distance of the virtual image from the mirror is same. So we can say that the image formed by a plane mirror is virtual, erect, and the size of the image formed by a plane mirror is equal to that of the object, and the image formed in a plane mirror is at the same distance behind the mirror as the object is in front of the mirror. So this distance and this distance is same. This distance and this distance is same. It means that the distance of object from mirror and distance of image from mirror is same, but there is a difference, one difference, and the difference is called as it is called as lateral inversion. Lateral inversion. Now what is this lateral inversion? If we stand in front of a mirror, plane mirror, we see image of our body in it, and the image appears like us only, but there is a difference. The difference is that uh, suppose you lift your left hand, it appears that the image in mirror is lifting right hand, and if you lift your left hand, it appears that the image is lifting the right hand. Okay, so the right side of our body becomes left side in the image, and the left side of our body becomes right side of the image. Okay, so this is called as lateral inversion. So the image formed by an extended object in a plane mirror is laterally inverted image. When the object is placed in front of a plane mirror, the right side of the object becomes the left side in the image, and the left side of the object appears to become the right side in the image. And this change of sides of an object in the mirror image is called as the lateral inversion. This phenomenon, which is the phenomenon of lateral inversion, is due to reflection of light. So now we can say that the image formed in a plane mirror is virtual. It is virtual because it is not real. And why it is not real? Because it cannot be obtained on a screen. The image formed in a plane mirror is erect. The image formed in a plane mirror is of the same size as the object, and the image formed by a plane mirror is at the same distance behind the mirror as the object is in front of the mirror. And the image formed in a plane mirror is laterally inverted.